In this video, we're going to look at some common cooling tower designs. By the end of the video, you will know about natural, mechanical, forced, and induced draft towers. Typically, natural draft cooling towers are only used where the cooling demand is high and constant. Thermal power stations, for example, often use natural draft cooling towers. Natural draft cooling towers rely upon the stack effect in order to obtain movement of air through the tower. Air is heated by the cooling water, and this causes its density to decrease. The warm air then rises above the cool air due to this density difference. In the tower, this means that the warm air moves upwards through the tower, whilst cooler air is drawn in at the base. Counterflow cooling towers force the cooling liquid in the opposite direction to the ambient air. For example, water will flow downwards due to gravity, whilst a fan forces air to flow upwards. The two mediums are thus flowing in opposite directions, 180 degrees apart. Cross-flow cooling towers force one medium to flow perpendicularly to another. That is to say, they flow 90 degrees apart relative to each other. If the cooling medium comes into direct contact with the process medium, the tower is a direct type cooling tower. If the cooling medium does not come into direct contact with the process medium, it is an indirect type cooling tower. For example, water being cooled by air is cooled directly. The water comes into direct contact with the air. But water in a pipe that is cooled by air is not cooled directly. The air cools the metal pipe, and the metal pipe then absorbs more heat from the water, which is then cooled by the air. Thus, the water is cooled indirectly.